Welcome to a lesson on an alternative method for adding mixed numbers that require an exchange. Let's first review the two most common methods taught for adding mixed numbers. Let's consider 6 2/3 plus 2 4/5. The first step is to obtain a common denominator, hopefully the least common denominator, which is the least common multiple of 3 and 5, which is 15. We begin by writing 2/3 and 4/5 as equivalent fractions with a denominator of 15. Notice for 2/3, we multiply the numerator and denominator by 5, and for 4/5, we multiply the numerator and denominator by 3. And then we add the fractions and add the whole numbers, which gives us 8 and 22/15. By now we need to recognize that 22/15 is an improper fraction, which must be converted to a mixed number and then added to 8, which gives us a final sum of 9 and 7/15. The second method would be to convert to improper fractions once we have a common denominator. Once we convert to improper fractions, we add and then convert back to a mixed number. Both of these methods can be somewhat involved, and therefore let's take a look at a new method called the compensation method. The idea behind the compensation method is that it's much easier to add a mixed number and a whole number rather than two mixed numbers. The first step in the compensation method is to obtain a common denominator, hopefully the least common denominator, which we already know in this case is 15. So looking at the equivalent sum in this form, the next step is to add a proper fraction or a fraction to one of the addends to make a whole number. In this case, let's say we want the second addend of 2 and 12/15 to be a whole number. Because 12/15 plus 3/15 is equal to 1, if we add 3/15 to the second addend, we would have 2 and 15/15, which is equal to 2 plus 1 or 3. But by doing this, the sum is going to be too large, and therefore the next step is to subtract the same fraction from step 2 from the other addend. So if we want an equivalent sum, if we add 3/15 to the second addend, we must subtract 3/15 from the first addend. So again, going back to the second addend, if we add 3/15, we have 2 and 12/15 plus 3/15, which is 2 and 15/15, which is equal to 2 plus 1 or 3. And then if we subtract 3/15 from the other addend, we have 6 and 10/15 minus 3/15, which gives us 6 and 7/15. And now we determine the sum. Because 6 plus 3 is 9, we know the sum is 9 and 7/15. Let's take a look at a second example. Let's consider 7 3/4 plus 4 2/3. The least common denominator is 12, and therefore the given sum is equivalent to 7 9/12 plus 4 8/12. Notice how if we add the fractions, we would have an improper fraction. To avoid this, let's use the compensation method. In this case, let's make the first addend, or 7 9/12, a whole number by adding 3/12. 7 9/12 plus 3/12 is 7 and 12/12, which equals 7 plus 1 or 8. But if we add 3/12 to the first addend to create an equivalent sum, we must subtract 3/12 from the second addend. And 4 and 8/12 minus 3/12 is 4 and 5/12. And now we can more easily determine the sum. Because 8 plus 4 is 12, the sum is 12 and 5/12. Just keep in mind, there's no reason to apply the compensation method unless, when adding the fractions, the result is an improper fraction. And we know this is not always the case when adding mixed numbers. For example, if we have 6 1/3 plus 2 2/5, after obtaining a common denominator, we have 6 and 5/15 plus 2 6/15. And notice how if we add the fractions, we have 11/15, which is a proper fraction, and therefore there's no need for the compensation method. If we did apply the compensation method, we can still find the sum, but it would take a little extra work. Notice here the sum is simply 8 and 11/15. Thank you for watching.